Now we are going to learn operations on set. The same with arithmetic or basic mathematics, we do have operations also, like addition and subtraction, multiplication, and division. Alright? So, the same with the concept of set, we do have also operations on it. And we have the first one, intersection of sets, union of sets, difference of sets, and complement of a set. Alright, so we will start first with what is set. Okay, this is just a review because I know before you come to the operations of set, you should tackle first the concept of set. So just a review, in set we use capital letters. Okay, this is very important so that we'll not get lost in studying the operations on set. You have to understand this one first. Okay, to denote set we use capital letters, and we also use lowercase to denote elements of set, and we use braces to list the elements of set and separate them in commas. For example, if we have this set A is equal to, you notice we use the braces here, and the elements are 5, 10, 15, 20. It means that 5, 10, 15, 20 are the elements of set A. And we use also this symbol, and we read this as an element of, meaning we use this symbol to represent the elements of a given set. Alright, so we will proceed now to the operations on set, and we will have, these are the operations, and we'll start with the first one, intersection of sets. Now by definition, intersection of sets A and B, written as intersection of set A and set B, is a set of elements that are members of both set A and set B. Now, let's take for example, we have this given the set A, set B, and set C. Okay, and we are asked to find the intersection of set A and B, and the intersection of set A and C, and the intersection of set B and C. So we'll answer the first one. Alright, so find the intersection of set A and set B. Now remember, the definition is that the intersection of set A and set B is a set of elements. Okay, put this in your mind, is a set of elements that are members of both A and B. So you will just look at set A and set B. What are the elements in set A that are present in set B? Okay, probably you've noticed it already that 2 is 1 present in set B? No, but 2 is present in set B. 3, is it present in set B? No. 4, is it present in set B? Yes. And 5, what about 5? Is it present in set B? No. And 6, what about 6? Is it present in set B? So what are the elements in set A that are present in set B? So we have 2, 4, 6. Therefore, the intersection of set A and B are 2, 4, 6. Alright, so let's answer the second example. What about intersection of A and C? So you will just look at set A and set C, and you will find immediately what are the elements in set A that are also present in set C, and therefore you can immediately answer that the intersection of set A and set B are 1, 3, 5. Why? because 1 is present in the element 1 in set A is present in set C, and the 3 that is present also in set A is present in set C, and 5 also in set A is present in set C. Therefore, the intersection of set A and C are 1, 3, 5. Let's go to the last example for intersections of set. So we will look at the intersection of set B and set C. You can immediately find if there are elements that are both member with set B or set C. Now you can see, and you've noticed this one, that there is no elements or element in set B that are present in set C. Therefore, what do you call that? If a set has no element, we call that as empty set or null set. Therefore, the intersection of B or set B and set C is empty set or null set. Okay? Now let's proceed to the second one. Union of sets. By definition, the union of sets A and B is written as union of set A and B is the set of all elements that are members of set A or all members of set B or all members of both A and B. Okay, so let's take a look on this example. We have a given sets here, set A, set B, set C. And the elements of set A, E, I, O, U. And set B, A, B, C, D, E. And the elements in set C are M, A, T, H. So we are going to find the union of set A and union of set B. Okay, and we are also going to find the union of set A and union of set C. And the next one, we are going to find the union of set B and C. Okay, so here's the solution. Here's our answer. Alright, so the union of set A and B are A, E, I, O, U, B, C, D. Why? Because union of sets are all members of set A and members of set B. Okay? So what you're going to do is you are just going to write all the elements of set A and set B, or the elements of the two sets where you get the union of those sets. So therefore, here is our answer. A, E, I, O, U, B, C, D. I know that you have a question. Sir, why is it the elements of B here, we have E and E, they get lost? We will answer that one later. Okay? So, what about example letter B? We have union of set A and C. Okay? So, all you need to do is you will just go back to the given, look at set A and look at set C. And what you're going to do is that you will just write all the elements of both sets, set A and set C. So first, you are going to write the elements of set A, where we have A, E, I, O, U. That's why we have it here. A, E, I, O, U. And look at set C also. Okay? So we have M, A, T, H. And that's why we write M, T, H. We don't write letter A. Okay? You might wondering why. I will answer that one later. Next, the union of set B and C. So what you're going to do, you will just go back to the given and look at the elements of set B and elements of set C and write all the elements in both sets, but don't write the element of sets that are repetition. Why? Because you have to take note on this. If an element is in both set, we list it once. That's the reason why in example number 1 or example letter A, the union of set A and B, we only write the A, E, I, O, U, B, C, D, and we don't write again the element A and E in set B because we have them already in set A. And if we have those elements in both set, by definition, we will just write it or list it once. Okay? Very good. So we will proceed to the next one. Difference of set. Now, the difference of set A and B written as difference of set A and B is a set of elements in A that are not in set B. Again, the difference of set A and B is a set of elements in set A that are not in set B. So let's take for example, we have this given set A, set B, set C. In set A, we have the elements R, O, Y, G, V, I, B. In set B, we have R, Y, B. In set C, we have B and Y. So, find. This is our example. These are our example. Set A or example A, we have difference of set A and B. Second example, difference of set A and C. Third example, difference of set B and C. So, let's get the answer. For example number 1, the answer is, or the elements, or the answer is O, G, V, I. Why? Because the definition of difference of set is a set of elements in A that are not in B. So look at this one. You will just go back to the given. Look at the elements of set A and set B. What are the elements in set A that are not in set B? There you go. There you are. You get O, G, V, I. So therefore, the difference of set A and B are O, G, V, I. We don't write R. Why? Because R is present in set B. We don't write Y because Y is present in set B. We don't write B because B is present in set B. Therefore, our answer for the first example is O, G, V, I. Alright? Let's go to the next example. Next example is difference of set A and C. So you will just look at set A, set B. And you are going to get, or you are going to find the elements in set A that are not in set B. Okay? So, what are the elements in set A that are not present in set C? We have R. That's why our answer here is R. That's why our answer here are R, O, G, V, I, B. Because these are the elements that are not present in set C. Okay? Next, difference of set B and C. All you need to do is you will just go back to the given set, set B and C, and you are going to find the elements or element that are not present in the second set. So what do you think is the element that is not present in the second element? We have R. Why? Because it's only element R that is not present in set C. Okay, very good. So, we will proceed to the next one, complement of a set. The complement of a set A, written as A having a apostrophe, is the set of all elements in the universal set. Okay, universal set that are not in a set A. So let's take for example, let's have an example here given. So this is our universal set. Remember that universal set is denoted by capital U. Okay? So we have here a universal set whose elements are 1, 2, 3, 4, 5. And we have given sets, set A, set B, set C. Set A, the elements are 1, 3, 5. Elements in set B are 1, 5. And elements or in set C, we don't have any elements. That's why we have here empty set or null set. So find complement of set A, complement of set B, complement of set C. So find the answer. We have complement in set A. Why? Why we got 2 and 4? Because by definition, complement of set A is the set of all elements in the universal set that are not in set A. So look at this one. You will just look at set A and the universal set. What are the elements in the universal set that are not present in set A? And if you get those elements, those are the elements or those are the complement of set A. Okay, so we have 1, 2, 3, 4, 5. These are the elements in our universal set. And we have also here set A. The elements are 1, 3, 5. So what are the elements in universal set that are not in set A? We have 2 and 4. Therefore, the complement of set A are 2 and 4. Next, complement of set B. All you need to do is you will just look at set B and the universal set and compare. Look at the elements of universal set and find those elements that are not in set B. So, you would immediately notice that 2 is not present in set B. Therefore, 2 is part of the complement of set B. And 3 and 4. These are the elements in the universal set that you cannot find in set B. So, therefore, these are the complement in set B. Next, complement of set C. In set C, we have how many elements in set C? No, we don't have because set C is an empty set or a null set. Look at this one. So, if you would compare universal set and set C, you will see that all elements in universal set are not in set C. So, therefore, the complement of set C are all the elements in the universal set, or you will just simply write U, denoted as the universal set. Okay? So, now we are going to have another problem using complement, and we will combine with other operations. Okay? So we have here problem number 1, or example number 1, example number 2, and example number 3. So we will answer this one. Okay? Now, what you are going to do in first example here, we have a complement of the intersection of set A and B. So what you are going to do first, in order for you to come up with the answer of this first example, you will just find first the intersection of set A and set B. So you would look at set A and set B, and you are going to remember what is intersection. And intersection are elements that are both present in both set, or set A and set B. So what are the elements that are present in both sets, in set A and set B? We have 1 and 5, because 1 and 5 are present in set A and set B. So therefore, the intersection of set A and B are 1 and 5. So if you have the value already for this intersection, or the operation inside the parentheses, you can get now the complement of this operation. So, what is the complement of the intersection of set A and set B? Since you have the value already for the intersection of set A and B, you can easily get the complement. All you need to do is you will just compare this one to the universal set. So what are the elements in universal set that are not present in your, or in the value of your intersection of set A and B? So you will have this answer 2, 3, 4, since elements 2, 3, 4 are not present in this in the intersection of set A and B. Okay? Next, for the next example, you are going to get the intersection of union of set A and set B. So what you're going to do first is that you will find first the union of set A and B. How to do that? You will, by definition, you remember it, right? That union are all members of both set. Okay? So, we have 1, 3, 5, the union of set A and set B. And you have to take note that if elements, it happened that the elements in set A is present also in set B, you will write it once. Okay? So that's why we have the union of set A and B are 1, 3, 5. So if you have the value already with the operation inside the parentheses, which intersection of set A and B, then you can get the complement. So the complement is the complement of intersection of A union B are 2 and 4. Okay? Next example, last example for complement of set. So we have here complement of set A intersection with the complement of set C. So first thing that you are going to do, you are going to find first the complement of set A. So we have here the complement of set A. By comparing the universal set and set A, you can get the complement of set A. So, we have here 2 and 4. And for the complement of set C, we have all the elements in the universal set since set C is an empty set or null set. Now, if you have the value already for the complement of set A and complement of set C, then you can get the intersection of both complement of A and complement of C. Since you have already the value for the complement of set A, which is 2 and 4, and you have also the value for the complement of set C, which 1, 2, 3, 4, 5, then you can get your answer for the intersection of complement of set A and complement of set C. So, therefore, your answer are 2 and 4. Okay? So, now, the same with the basic math or the arithmetic, you remember that in one problem, you can also use all those operations like addition, subtraction, multiplication, and division. The same with the operation on sets. You can use all of these operations at the same time in one problem. So let's say, for example, we have here, we have the universal set, set A, set B, set C. So find the following. We'll have two examples here. The first example, second example, set A or example A and example B. So in example A, how many operations are used? We have intersection and union. What about in the second example? How many operations do you see in this example? We have the first one, intersection. We have also the complement. We have also the difference. Therefore, we are using three operations on set in this example. So let's answer the first one. Okay? So here is the solution. Now, in order for you to answer this one, you need to find first the value of those sets that are enclosed with the parentheses. Okay? So the first one, the intersection of set A and B. So if you would look at set A and B here, what is the intersection? It's only 5, the element 5. Why? Because 5 is present in set A and set B. So that is the intersection for set A and set B. Second one, since you have the value for this, find the value of the second set that is enclosed by the parentheses. So, we have set B or intersection of set B and set C. And if you would look at set B and set C, you can immediately see that it's only 2 and 6 that are the elements that are both present in both sets. Therefore, you have 2 and 6. And lastly, since you have the value for those sets that are enclosed with the parentheses, you can perform the indicated operation in the center, okay? Which is the union. So since you have the value for this one, which is 5, and the value for this one, which is 2 and 6, then find the union. And the union by definition, all the elements that are present in both sets. So we have 5, 2, and 6. That's why we have here our answer. Okay? So let's proceed to the second problem here. And here is our solution. Intersection of set A and set B. So if you would look at that one, the intersection of both sets is only 5. Since element 5 is only the element that are present in both sets. Okay? So next, since you have already the value with the enclosed of the parentheses, we have here the complement. Find the complement of this set enclosed with the parentheses. So since it is 5, then you would look at the universal set and you will see that 2, 3, 4, and 6 are the complement. Okay? So, next. Since you have the value for this, you will find also the difference between the universal set and set C. So if you would compare it, you will immediately see that the difference is 3, 4, 5. Why? Look at the universal set. What are the elements in the universal set that are not present in set C? And you would immediately see that it is 4, 5, 3. So, since you have the value for this, and you have also the value for the second one, you can perform the indicated operation in the center. So, you have here 3 and 4. If you get the intersection of the complement of intersection of set A and B, and the difference of universal set and set C. Okay? Now, here is our takeaway. So, in real experience, we use the concept of set. And in mathematics, we use also the concept of set. And also in the Bible, we can also see that the Bible is using the concept of set. Let's say, for example, in 1 Peter 2, verse 9, it says there that, "But ye are a chosen generation, royal priesthood, and holy nation, a peculiar people, that ye should shew forth the praises of him who hath called you out of the darkness into his marvelous light." So you see in here that God is also using the concept of set. And God has a set of people. And do you want to be an element of the set of God's people? Yes, me too. I want to be part of God's people. For what purpose? And that is to show praises of Him who called us out from the darkness into His marvelous light.